All right, good afternoon. So today we're going to talk about systems of equations, all right? And in intermediate algebra, you probably did 2 by 2s here. In pre-calc, we're going to go ahead and do a 3 by 3. Okay, these are a little bit harder. They're a little bit more tedious, okay? So we're going to write each of the equations in standard form. They usually do this for you. We're going to choose a pair, and we're going to eliminate one of the equations, one of the variables from that pair. We're going to do the same thing. So the algorithm I'm going to show you might take a little bit longer for the general, for a specific problem, but it'll be shorter in the long run for a general problem. Um, if you don't follow an algorithm and you just kind of go at this as is, um, trust me, I've given this to other students and watched without giving them the algorithm, and rather than do it in about 6 steps, it was about 20 for them to finally get done. So I urge you to use an algorithm most of the time, but if you see a shortcut on something or you see a way of going a little bit faster, you're invited to do that. Many of my former classes always ask me, but can't we just? Like, absolutely you can just. But you know, if you haven't had coffee or you haven't, you know, you're not really you don't really see it, then this algorithm is going to be a better case for you. So the goal here is we are going to eliminate the x's. Okay, we are going to eliminate the x's from the first column. So we're going to knock out for those two rows. Then we're going to eliminate the y, and we're going to knock it out of that row. Okay, the final form will be something called triangular form. Okay, so you'll see why as soon as we get done. All right, so let's go through and start this thing. All right, so I'm just going to go ahead and rewrite equation 1. Okay, we're going to go ahead and name these. We'll call this equation 1. We'll call this equation 2. We'll call this equation 3. So equation 1 we'll have written as negative 3x plus y plus z is equal to negative 4. And what I'm going to do is I'm going to multiply negative 3 times equation 2. Right? So negative 3 times equation 2. So that'll give me a positive 3x, okay? Negative 3 times negative 1 with a minus 6y and a plus 6z. Don't forget the right-hand side. I know that's very common. All right, so we're going to end up with negative 3 on the other side here. All right, so let's go ahead and do this arithmetic. Okay, you can guess why I wanted to multiply by negative 3 now, because that cancels. 1 plus negative 6, that's going to be negative 5y. Okay, 1 plus 6, that's going to give us 7z. And we end up with negative 7 on the right-hand side there. Okay, now I'm going to pick equation 1 and equation 3. So I'm still going to, well, actually I'm not. I'm going to say 2 times equation 1. All right, and that's going to give me negative 6x plus 2y plus 2z is equal to negative 8. And we're going to say 3 times equation 3. So if I say 3 times this 2 here, we end up with a positive 6, okay? So we end up with a positive 6x, okay? We have a minus 3y minus 3z, and that is equal to negative 3. I want to add these together, right? The x's cancel. We get 2y minus 3y. 2y minus 3y is going to be negative y. 2 minus 3z is going to be negative z, and that is equal to negative 11. Now, I'm going to multiply both sides of this equation by negative 1 just to keep things a little bit neat here, and we're going to end up with a y plus z is equal to 11. Okay, so let's summarize. Okay, this is our new equation 2. This is our new equation 3. So let's just go ahead and rewrite this problem from the beginning with our new equations in there. So we have a negative 3x, we have a plus y, we have a plus z, and that is equal to negative 4. Our new equation 2 looks like negative 5y plus 7z, that is equal to negative 7. And finally, we have our new equation 3, which is just y plus z equals 11. All right. So the plan now is we're going to eliminate this y from the third equation here. So we're going to write down equation 2, our new equation 2, negative 5y plus 7z equals negative 7. And I'm going to multiply 5 times my equation 3. So we have 5 times y, which is 5y, plus 5z, and that is equal to 5 times 11, which is 55. All right. So let's go ahead and add those together. We end up with 0 y's. We end up with a 12z, and this is equal to 55 minus 7, which I believe is 48. And I think we could say then that z is equal to 4. Okay, so here's why it's called triangular form, because when I'm all said and done here, my summary here is 3x, negative 3x plus y plus z is equal to negative 4. We have negative 5y plus 7z is equal to negative 7. And then we have z is equal to 4. The idea here is that we're going to use this z is equal to 4 to back substitute into the second equation and then back substitute into the third equation. So if I go ahead and substitute in, we've got minus 5y plus 7 times 4 is equal to negative 7. So this is negative 5y plus 28 equals negative 7. Negative 5y, if I subtract 28 from both sides, we're going to have a negative 35 on the right-hand side. Divide both sides by 5 here, we're going to have y is equal to 7. All right, so far we've got z is equal to 4, y is equal to 7. All right, and then we're going to go back to our first equation, right, back to our z, and we're going to say here is negative 3x plus, what the heck is y? Y is 7, plus what is z? Z is 4, and that's equal to negative 4. Okay, so this is going to be 3x, negative 3x plus 11 is equal to negative 4. Subtract 11 from both sides. Negative 3x is equal to negative 15. And I think we could say that x is equal to 5. Okay, so to summarize all of this, we have x equals 5, y equals 7, z equals 4. You definitely want to end your problem with something like this, okay, rather than make somebody go through and chase down your solving throughout your problem, because that might be a pain to do that. Or if you're in a hurry, to finish a solution, you have to here's the solution you're going to give to your boss. You don't want to make them go through all your work to do that. Okay, so that's how you solve something like that. Um, there's another type. Okay, this is called a consistent solution. Okay, it's independent because each of the variables is equal to a value. Now, if you got x equals 1, y equals 1, z equals 1, that would still be consistent and independent. The fact that they're all the same, that doesn't matter. That's not what independent means. We're going to do a dependent system in the next example coming up, so you'll be able to see how they're different. Okay, so let's go ahead and look at our next example here. All right, so we have an example. We have our equation. We have 2x minus 3y plus z is equal to 1. X plus 4y minus z is equal to 3. And 5x minus 2y plus z is equal to 5. All right. So let's go ahead, and what we're going to do is I'm going to write down equation 1 here. Okay, so we have 2x minus 3y plus z is equal to 1. We have 2 times equation 2, and that's going to give, actually, let's go with negative 2 times equation 2 here. Yeah, so that's going to give me a negative 2x minus 8y. Negative 2 times 1 is positive 2z, okay? And that's equal to negative 6. So let's go ahead and sort that out. So that cancels. We end up with negative 11y plus 3z. And then we have 1 plus negative 6. We're going to end up with a negative 5 there. Okay, this is my new equation 2. All right, let's go ahead and let's multiply 5 times equation 1. Okay, and that's going to give us, I want to do 5. Yeah, let's do 5 times equation 1. So let's go ahead and it's going to give us 10x. Okay, 5 times 3 is minus 15y plus 5z. And 5 times 1, of course, is 5. And then we're going to do negative 2 times equation 3. Okay, negative 2 times equation 3. So that's going to be equal to negative 10x, okay, plus 4y, okay, minus 2z is equal to negative 2 times that. That's going to give me negative 10. And let's go ahead and add that and sort that out. Okay, so that's the x's are going to cancel. We've got negative 15y plus 4y. That's negative 11y. And then we have 5 minus 2. That's going to give me a plus 3z. And if we add these two together, we should get a negative 5. And then let's go ahead and summarize. You may have noticed something already. So we have equation 1. Okay, this is our new equation 3, by the way, right here. Okay, this is our new equation over here. This is 2. All right. So we have 2x minus 3y plus z is equal to 1. We have negative, let's go ahead and erase that. Go back to a pen. Okay. We have negative 11y plus 3z equals negative 5. And then for our third equation, we have negative y plus 3z equals negative 11 or negative 5. I could swear I've seen this equation somewhere before. Oh yeah, it's there. So in my next, if I follow my algorithm, I'm going to eliminate this y from equation number 3. And I think it's pretty obvious that if I take row 2 and subtract row 3, what we're going to end up with is 2x minus 3y plus z is equal to 1. And we have negative 11y plus 3z equals negative 5. We have 0 equals 0. Right? Now, if it's inconsistent, what's going to happen is that this 0 isn't necessarily going to be, this would not be a 0. You would get, so this is fiction. This is not part of the problem. If we ended up with something like that, 0 equals 3, we'll say, well, that's utter nonsense. So we have an inconsistent system. Okay, that's what an inconsistent system looks like. Okay, what a consistent but dependent system looks like, oops, let's go ahead and, well, let's not get rid of it, but let's just cross this out. This is not true. Okay. So what a dependent system looks like is when you get this 0 equals 0 business, because what happens is I don't have enough equations to solve for my variables. Okay. Now your book doesn't do this, but more advanced textbooks do. And for the life of me, I can't fathom why they do this, but I think it's to let the reader know you solved the equation and it's a dependent system. But we're going to say let z equal to some parameter. Okay, let t equal z. Let z equal t. So what we're going to do here is we're going to say this is, let's just work on equation 2. Okay, we have negative 11y plus 3t is equal to negative 5. Okay, so that's negative 11y plus 3t equals negative 5. Oh, that's delightful. Okay, there we go. So let's make a proper negative 5 here. Okay, so we have negative 11y is equal to negative 3t minus 5. If I divide both sides by 11 here, we end up with y is equal to 3/11 t plus 5 over 11. The negative sign changed the two signs here. Okay, continuing our algorithm, because we're just going to roll this up into the first equation, we have 2x minus 3y. So y is equal to 3/11 t plus 5/11. Okay, and then we have a plus t here for the z. This is equal to 1. So we have to sort this out. That's going to be 2x minus 9/11 t minus 15/11. I'm going to go ahead and say 1 is equal to 11/11 t is equal to 11/11. Right? We'll continue this on a page down here. So we have our 2x. Okay. This is going to be minus 9 plus 11. So this is going to be plus 2/11 t minus 15/11 is equal to 11/11. Right, let's put this on the other side. Let's scoot this over to the other side. We have 2x is equal to, go ahead and add 15 to both sides. So 15 and 11 is 26/11 minus 2/11 t. Divide both sides by 2. We get x is equal to 13/11 minus 1/11 t. So our solution here, okay, x equals, right, x equals 13/11 minus 1/11 t. We have y is equal to 5/11 plus 3/11 t. And we have z is equal to t. And this is a dependent system. All the values are dependent on this t parameter we've chosen. If you end up with having more than one parameter that has or more than one variable that has a 0 row, then you're just going to have more than one parameter. You might have an s and a t. You might have an s, t, u, and v. It just depends on how big your problem is. Okay, but we have infinite solutions, and they all take this form. So whatever I pick for t, we can go ahead and plug this in, and we'll end up with a solution that works. So it's consistent, but dependent, since we have this t variable sitting here. Okay, so thank you very much, and go ahead and try a couple of these, and we'll see how we go.